Hi everyone, here is your introductory lecture video to section 3.2 in which we are going over the graph of a function. The set definition that we have here for a graph is the following. The graph of a function f of x is the set of all points x comma y such that x is a real number and y is written as a function of x. Remember that in this class we're usually talking about real valued functions, and so this is the definition that we have here for real valued functions. So the set of all points x comma y that satisfy the equation y equals f of x. So something that we want to remember is the following. If a point is on the graph of a function, it satisfies the equation of that function. I also wrote here, and vice versa. So if you have a point that satisfies the equation of a function, that point is going to be on the graph of the function. So recall this definition of a function that we had in section 3.1. A function is a relation with the requirement that every input from the domain maps to exactly one output in the range. So every input has exactly one output associated with it. So the graph of a function is a set of all points that satisfy the equation of a function. If you're given the graph of a function, can you determine if it is if you are given the graph of a relation, can you determine if it is a function? The answer is yes. The test that we have for this is the vertical line test. A set of points in the xy plane is the graph of a function if and only if every vertical line intersects the graph in at most one point. So if and only if every vertical line intersects the graph in at most one point. Let's take a look at an application here involving this vertical line test. So here I have a question involving two graphs, and the question is, which graph is a function? Number 1 or number 2? Number 1 is a function. Why? No matter what vertical line you draw, that vertical line, no matter what vertical line you draw, it will touch the function in at most one point. You can see that here. Number 2 is not a function. Why? For number 2, there are vertical lines that we can draw that will touch the function in more than one point. Take a look here. If I draw a vertical line right here going straight down, you can see here this vertical line will pierce the function here, here, and here. So it should be clear to everyone that number 2 is not a function. Oopsie. I just now erased the graph there on accident. I'll have to fix that after this video, I suppose. So from section 3.1, we know that the domain f of a function is a set of all allowable inputs x. The range of a function f is the set of all outputs y. If you are given the graph of a function, can you find its domain and range? The answer is yes. If you are given the graph of a function f of x, the domain is the set of all x values going from left to right. The range is the set of all y values going from bottom to top. So here's an example that we will talk about tomorrow. You'll notice here that this has parts A through I. In this video, I am not going to do all the parts. I'm just going to do parts A and B. We're going to do the rest of the parts in class tomorrow. So this is an example that we will talk about tomorrow. So what do you have here in this example? You're given the graph of a function f. It's right here on the top left of the screen. We're going to work on parts A and B of this problem. We need to find the domain of this function and also the range of this function. So how do we find the domain? Let me scroll back up one more time. The domain of a function, if you're given the graph, is the set of all x values going from left to right. Looking at this graph, if I look at the x values on the graph going from left to right, you can see here that we have this arrow pointing downwards, right? This means that we can continue to plug in negative numbers for x, and our outputs are going towards negative infinity. Looking at the graph, we can plug in all of these x values from negative infinity all the way up to positive 3, and then there's a gap, right? There's a gap in the function. The function continues for x values between 5 and 6 inclusive. So what's the domain of this function? Going from left to right, your domain is going to be the following. It's going to be all of the x values from negative infinity to positive 3 with a bracket. The brackets are used to include a value. We also have to include the interval from 5 to 6. So I'm going to have to use a union, and then I have bracket 5, 6. What about the range? Let me scroll back up. The range is the set of all y values going from bottom to top. If we look at this graph, going from bottom to top, well, we know that this graph is going towards negative infinity, as evidenced by the arrow pointing downwards. So I have to have this for part of my answer in interval notation. And then what? You'll notice that the graph goes all the way up to 3, then it goes back down. But then from 5 onwards, what happens? The graph goes up all the way to positive 4. Remember that your range is a collection of all the outputs. This is going from bottom to top. From bottom to top, we are hitting all of these y values from negative infinity all the way up to positive 4. So my range is the interval from negative infinity to positive 4 with a bracket on 4 because we attain that value. Alrighty, everyone, that about wraps up this video. Remember that we are going to be talking about this example tomorrow in class, and we will be working on the remainder here of these parts of this problem. I will see you in the next one.